the today's discussion, we will be starting a new journey in terms of discussing about the clustering based approaches, which is very widely used in unsupervised machine learning based tasks. So what is the meaning of unsupervised based tasks? Majorly any task where by observing the data set, you will observe that the target column or the data is not labeled. So until so far, whatever things we have explored, whatever things we have discussed, we have seen that in our data set, we have a target label available with us, right? There will be always one outcome column, which will be, if it's a classification task, either 0 or 1. If it's a regression based task, it might be some continuous number. But now onwards, in today's discussion, we will observe that the data that we will be dealing with does not have any labels, does not have any linked target values. Now, what we want is, we want to still identify the similar patterns and group the data points which are having a similar pattern. And that's grouping is what we call as a clustering in the case of a unsupervised machine learning. Now, how this clustering will work, how can we make the clusters, what does that signifies, all of these things we have to understand. So shall we start? I think everybody is comfortable in terms of agenda of today's discussion. So let me share my screen and you guys can confirm to me if my screen is properly visible to everyone. Visible? Perfect. So when we talk about the clustering algorithms, what we have learned, that these algorithms are designed for specially unsupervised machine learning tasks. Machine learning tasks. Now, what is the meaning of unsupervised machine learning tasks? That's also we have covered up. The simple meaning is that here we are discussing about the unlabeled data or data in which there is no as such target column. There is no target column available. I think this part is pretty much clear to everyone, right? Now we have to understand that, first of all, what are the applications of this specific part? Any guesses? Anyone? Anywhere in the real-time scenario, have you seen any sort of applications for the same? Anybody? क्या लगता है क्या एप्लीकेशंस होंगी कहां पर हम अनसुपरवाइज्ड मशीन लर्निंग टास्क को परफॉर्म कर रहे होंगे एनी गेसेस एनीवन where data is sorted in a categorical form. No, that's not true. That is not true. So what are the applications where we are using this unsupervised machine learning task? That's the question. So have you seen customer segmentation. Customer segmentation. What does this problem says? For example, depending upon different customers, right? उनकी purchasing power कैसी है, how much salary they are earning on a monthly basis, they will definitely have a different sort of categories. अब हमें नहीं पता कि उनके corresponding labels क्या है, and you know there is no one who is like manually sitting की label करेगा कि ये customer जो है वो one category को belong करता है, दूसरा customer two category को belong करता है, and so on. That is not feasible, right? So what usually happens, for example, uh, let's take an example of a banking domain over here. अब let's say कोई customer बैंक के पास जाता है to get the loan. अब बैंक directly तो loan नहीं देगा. That bank will check कि that person how much he is earning, what is the CIBIL score that specific person do have, right? Depending upon that, definitely that person will get the loan of any specific amount. ऐसा नहीं है कि उसको किसी भी amount का randomly loan मिल जाएगा. Now there are multiple features which that customer is linked with. Now, for example, that customer will have maybe the monthly salary जिसकी डिटेल बैंक के पास होगी. दैट कस्टमर विल बी हैविंग अ सिबिल स्कोर, मतलब कि उसने अगर लोन ले रखा है या फिर क्रेडिट कार्ड यूज करता है तो उसका सिबिल स्कोर अच्छा है कि नहीं. मे बी दैट कस्टमर वेयर एक्चुअली दैट कस्टमर इज स्टेइंग करंटली, एंड डू दैट कस्टमर हैव ऑलरेडी अवेलेबल एसेट्स और नॉट. कि अगर वो बंदा लोन नहीं चुका सकता तो उस स्पेसिफिक केस में क्या हमारे पास बैंक के पास कुछ ऐसे एसेट्स हैं जिसकी हेल्प से वो बंदा मतलब अगर लोन ना चुका पाए तो बैंक उस स्पेसिफिक एसेट को यूज कर सके. नाउ डिपेंडिंग अपॉन दिस सैलरी, मे बी बैंक्स कैन कैटेगराइज द कस्टमर्स इनटू 3 कैटेगरीज. एक ऐसे पैटर्न के लोग होंगे जिनकी सैलरी लेट्स से मंथली बेसिस पे मोर देन 5 लाख हो. मे बी दे हैव कैटेगराइज दिस एज अ कैटेगरी नंबर 1, और मे बी द प्रीमियम कस्टमर्स. Then there will be a customer category second, जहां पे लेट्स से कि उनकी सैलरी 2 से 5 लाख के बीच में होगी. लेट्स अज्यूम ये एक तरीके से मॉडरेट कस्टमर हो गए बैंक के. फिर एक और कस्टमर की कैटेगरी है इन विच दे आर अर्निंग लेस देन 2 लाख, लेट्स से. So here we will be having 3 categories of customers. This is the C1, this is the C2, this is the C3. Now C1 customers group are those customers group who are earning more than 5 lakh. So उस specific instance में they have this common pattern. C2 category is the one for the customers who are earning between 2 to 5 lakh. And C3 customers are the ones who are earning less than 2 lakh. So in all of these 3 use cases which we are talking about, we have to do a segmentation task. We have to actually identify the similar patterns. We don't have a label data. So in these scenarios, you have to use these clustering approaches in order to segregate this. I hope it is clear to everyone. The very first example, the very first use case, the very first real-time application of clustering approach. Clear हुआ? What I'm trying to convey over here? All good? चले आगे. Just to give you a relatable real-time example, let's suppose कि आप Big Bazaar में गए. I hope everybody used to go there. Big Bazaar, Smart, whatever be the brands we will be having, where we used to buy the grocery items. Let's suppose कि you went to Big Bazaar. Now, let's say it's your first day and you are going there to work in the Big Bazaar store. ठीक है? अब for example, today there are new items, stock comes up in that specific store, and let's say that is the dals categories. अब let's suppose कि अगर आपको दालों को रखना है एक proper allocated space पे, तो do you actually need a training over there? Or what will you do? So it's your first day, and let's say कि new stock is coming in the store, and the person or the manager said कि this is the stock of dals. You have to put it in its associated place. So do you guys need actual training for the same, or you can do that easily? And if you can do that easily, how will you do that? कैसे करोगे? पहली बात तो कर सकते हैं कि नहीं कर सकते, क्या इस चीज में हमें ट्रेनिंग चाहिए, दैट इज द क्वेश्चन. दूसरी बात, अगर कर सकते हैं तो हाउ विल वी डू दैट? टेल मी, कैसे करेंगे? इतना मुश्किल क्वेश्चन तो मैंने पूछा ही नहीं. Based on grouping who look similar kind of. Very good, Khushbu. So नहीं, यहाँ पर लेबलिंग एज सच नहीं है, यहाँ पे ग्रुपिंग है. तो व्हाट खुशबू हैव मेंशन्ड इज करेक्ट. आप देखोगे कि कौन से स्पेसिफिक डेटा पॉइंट्स जो हैं वो दाल की कैटेगरी में बिलोंग करते हैं. मतलब कोई तो स्पेसिफिक एरिया होगा जहाँ पे सारे दाल रखी होंगी, एंड यू विल गो टू दैट स्पेसिफिक एरिया एंड पुट the linked dal over there. Same thing is happening when a new test data comes into picture. In the clustering approaches, there is no as such labeling we have, but we have the clusters, we have the groups available. Now the test data will check that whether I belong to C1, whether I have a similarities matching with C1 or C2 or C3. And accordingly, it will put that data point with respect to C1 or C2 or C3. So that is the overall idea behind this clustering approach and how this grouping will be done. The important thing why this specific concept comes into picture, because it's very difficult to label every kind of a data. मतलब ठीक है, अभी तो वी आर इन अ वर्ल्ड जहाँ पे फिर भी हमारे पास लेबल डेटा बहुत हद तक अवेलेबल है. बट when we started this journey of collecting the data, obviously initially labeling was the number one trouble. हर एक डेटा लेबल नहीं है, और लेबल कौन कर सकता है? ओनली द डोमेन एक्सपर्टीज कैन लेबल द डेटा. So that is where this unsupervised machine learning technique comes into picture. Somehow ये labeling ही provide कर रहे हैं हमें, but via machines, not via the actual human beings. तो automatically patterns को check करके it will start detecting the automatic labels or the clusters that we are talking about over here. Now, in this specific part, we have three important algorithms which we will discuss today. One is the k-means clustering algorithm. Second one is the hierarchical clustering algorithm. And the third one is the DBSCAN. So these are the three important algorithms that we have as a core part of the clustering algorithms. So shall we move ahead and discuss about these algorithms? चलें आगे? Everyone? So सबसे पहले we will talk about this k-means, how it works internally, and then we will do the implementation, and then after that we will start the further algorithms. So are you guys ready? K-means clustering. So you can see, again, this is the article for first discussion that we are doing today. You can refer at your end. So you can see what usually happens. This is the first step, initialization of centroids, then updating the value of the centroids, assigning the points to clusters, and then convergence check. So I will talk about all of these steps, what will happen one by one. So I hope you can see this diagram, right? Let me just fetch this specific diagram. So here you can see we have, let's say, this data points. Now this is a unlabeled data. That's what we are talking about. That is where we are using a clustering approach as well. Now what will happen is, in the initial part, we don't know that how many clusters we should apply. Currently, this K represents the number of clusters. K represents the number of clusters. And for now, I am assuming that this number is equal to 3. We will talk about this discussion again in a later part of the session, that how can we choose the best value of K. But yes, in the starting, the very first step in this K-means clustering is to define the value of K. Define the value of K. K means the number of clusters which you want to form in your data. So when you are saying that the value of K is equal to 3, it means that it will randomly initialize the 3 centroids. Can you see this cross symbol? These 3 centroids are there. So you can see over here, this cross symbol represents the centroid in this picture. Now, once it will try to initialize these centroids, so let's assume that this centroid is C1, this is C2, this is C3. So when it tries to take 3 centroids, C1, C2, C3, what will happen is, whatever be the data points that we will be having, let's assume that अभी हम assumption की basis पे काम करते हैं. Let's say कि we have a 10 points available in my data. So we have C1. We will try to see the distance of C1 with respect to P1, P2, P3, P4, P5, P6, P7. Let's say अभी 7 ही लेते हैं. Now same thing it will try to do and find out the distance with respect to C2. And the same thing, it will try to find out the difference with respect to C3. ठीक है? यहाँ पे कुछ गड़बड़ हुआ है. So I hope it is clear कि हर एक centroid से it will try to find the individual points that we will be having. Now, how this distance will be measured? Any guesses? Centroid जो हमने define किया, उससे जो points का distance निकाला जा रहा है, P1 से लेके P7 तक, considering that we have only 7 points for now available in our data. So how this distance evaluation will be done? Do you have any guesses? If you can recall what we have learned in KNN. Acha, by the way, there is a lot of confusion between K-means and KNN because these names look same. As a beginner, people usually get confused. But I hope you all remember, KNN is a supervised machine learning technique. K-means is what we are learning under the unsupervised machine learning technique. Here, K represents the number of clusters. In the KNN, K represents the number of nearest neighbors. So don't ever get confused between these two algorithms. So as Khushbu mentioned, that yes, the distance metric could be Euclidean. It could be Manhattan, the way we have covered up. So here, let's suppose for now that the centroids distances will be evaluated for all the given points, maybe via the Euclidean measure. Maybe via the Euclidean distance. Now, what is the meaning of Euclidean distance? It will be square root of, let's say, centroid position will be x1, comma y1, and the points, or maybe x, comma y, and the points location is x1, comma y1. So it will be nothing but x1 minus x whole square plus y1 minus y whole square. So similarly, it will try to evaluate the distance from P2 with respect to P3, with respect to P4, with respect to P5 till P7. Okay. Now, after doing this evaluation, listen it very carefully. It will try to see that what are the points closer to C1? What are the points closer to C2? What are the points closer to C3? For example, let me give you one example. The distance from C1 to P2 comes out to be 4. The distance from C2 to P2 comes out to be, let's say, 2. The distance of C3 to P2 is coming out to be, let's say, 6. So now this P2 points belongs to which cluster? सबसे ज्यादा पास किसके होगा? तो मैंने क्या बोला? C1 का P2 के विद रिस्पेक्ट लेट से डिस्टेंस है 4. P2 का C2 के विद रिस्पेक्ट डिस्टेंस कितना आ रहा है? Here it is 4. Here it is let's say 2. एंड थर्ड केस है हमारे पास P2 का C3 के विद रिस्पेक्ट है लेट से 6 लिखा है ना मैंने. सो कौन से क्लस्टर से ये जो पॉइंट P2 है ये पास होगा? सो यू विल से इट विल बी क्लोजर टू C2. तो वो C2 का पार्ट बन जाएगा. सो दैट इज हाउ दिस, let's say these are the points which you can see over here. These all points are closer to C2. तो वो इसके पार्ट बन गए. C1 के क्लोजर जो पॉइंट्स बने थे वो C1 के पार्ट बन गए. C3 के क्लोजर जो पॉइंट्स बने थे वो C3 के पार्ट बन गए. सो यू कैन सी ऑल ऑफ these are the 3 clusters that we will be having. Does that make sense? Clear हुआ what I'm trying to convey over here? All good? In this way we will be able to form the 3 clusters that we will be having. तो हमने क्या किया? सबसे पहले वैल्यू ऑफ k को डिफाइन किया. Then what is the second step? Second step is finding the nearest points corresponding to each centroid that we will be forming. All good? If C1 and C2 both are at same distance equals to 2, in that case it can go to any one of them, maybe C1 or C2. In that case there will be a clash. तो किसी भी point से वो belong कर सकता है उस case में. Done? Now what is the third task? Once this is done, after that it will try to find the average of all points available in each cluster to find the new centroids. अब इसका मतलब क्या? समझ में आया? To find the new centroids. What does that mean? It simply means कि let's say हमारे पास 3 clusters available हैं. अभी क्या करेगा वो? हर एक C1 के corresponding जितने points है उसका average निकालेगा. C2 के corresponding जितने points है उसका average निकलेगा. C3 के corresponding जितने points है उसका average निकलेगा. Average से क्या आएगा? एक नया centroid आएगा. अब ऑब्वियसली आपके C1, C2, C3 की वैल्यू चेंज हो जाएगी और एज पर द न्यू अपडेटेड वैल्यू ऑफ C1, C2, C3 अगेन इट विल ट्राई टू फाइंड आउट द न्यू डेटा पॉइंट्स दैट वी विल बी हैविंग. तो फिर से वो वही स्टेप रिपीट होगा. नए C1, C2, C3 के लिए वो फिर से क्लोजेस्ट पॉइंट्स निकालेगा. फिर से वो पॉइंट्स निकालने के बाद फिर से वो एवरेज निकालेगा जो हमारे क्लस्टर्स आए उसका. एंड दिस प्रोसेस विल कीप ऑन रिपीटिंग until it reaches to a point जहां पे एवरेज निकालने के बाद आपके सेंट्रॉइड्स चेंज होना बंद कर दें. सो द पॉइंट इज दिस प्रोसेस keeps on repeating until the model reaches to a point, not we are not doing it manually, until the model reaches to a point where it stops updating the centroid. Position. you can say. Is this clear? इसका मतलब अब हम एक ऐसी पोजीशन पे आ गए जहां पे we will be able to find the stable, I would say, clusters. That is the main idea. Is this part is clear to everybody? Everyone is comfortable? समझ में आया what I have told you? Any doubts in this part, please go ahead and ask, and then we can proceed ahead. Yep. Is this clear? समझ में आया? Any doubt in its internal implementation, how it works? If you have, please go ahead and ask from me. So I was looking for the some interactive dashboard also, if I could be able to find out. So I find out one, not really sure how it will work. So you can see here we will be having these different I would say clusters. You can see 5 points are there. Number of clusters are 5. Points are 200. Method is pure random. Uh, so you can reinitialize, iterate the algorithm. And these positions which you can see, right? This black marker, these are the centroids that we will be having. Again, if you will run, you will get some new centroids. Again, you will get some new centroids. Again, you will get some new centroids. Again, again. And you will see in every iteration, it is able to betterly distinguish between these 5 clusters. If you can see its line, how these clusters are distinguishing. In every iteration, we are reaching to a stage where we can better classify these 5 classes that we will be having, these 5 clusters that we will be having, with the help of the centroid movement. Now, this movement will keep on going until it reaches to a stage where these centroids will be fixed in its location, where when it will try to find out the average coming out to be same after some point of time. So it is still moving, but now the movement is very slow. And here we go. Now you can see I am clicking on this iterate button, but now it is not moving. It means now we reach to a point where centroid's position gets fixed. Means now I will be able to get a stable cluster, which you can clearly see ki how beautifully now I will be able to classify orange, green, violet, or purple, you can say red, and this blue dots very easily. So I will reinitialize. You can see this is the initial structure. Again, I am repeating my point. Let me just zoom it a bit. You can see here are my centroids, these black positions. If you will click on this iterate position, it will change the centroid position, because again it will try to find the nearest point and then taking the average. Click on iterate, again movement is happening. Iterate, movement is happening. And in every movement you will observe that it is actually locating a better uh, grouping, in a way that there will be no collision between green and blue, green and orange, green and purple, and so on. Then we will move further. Again, there is a movement. 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 Again, it is locating. Again. But now, if you will click again, no movement is happening. Means now it reaches to a stage where if you are, it is internally finding out the average of the points, but it is getting a same value. And that is why now the positions are getting fixed. Clear ho gaya? Is this clear? I have tried to showcase you mathematically also, and uh, via this demonstration also. Is this fine now? कैसे वो एक अच्छे clusters को बना पा रहा है? All good? Can I get a quick confirmation from everyone in the chat? Perfect. So here implementation, so we will see anyhow. Uh, so you can refer this video as well. I think this is also my videos only. So you can refer both of them and you will be able to get the similar kind of explanation, but it might be uh, quite intuitive to understand further. But yep, this is the main idea. Now, what are the applications in a real time? In a real time, almost in all the segmentation based scenarios, for example, just now I have talked about the customer segmentation case, right? So, wherever you want to find out the similar patterns, so that is how actually the grouping is being done. K-means is one of the very widely used and the famous algorithm in the industries. So, this is how it works and helps us to get the patterns, to get the groups, to get the clusters. And in that sense, we will be able to find out the different segments that we will be having in the customer segmentation part, right? So, yep. Shall we move ahead now to the implementation of this k-means so that we will be able to get a more intuitive idea on how it works in a practical scenario, in a real time scenario, if everybody is comfortable till so far. Chale aage? Perfect. So now what I will do is I will open the drive. Just give me a moment. How we will decide the value of k will come to that point after this discussion. Again, here also we will discuss about the elbow method, which helps us to give us the best value of k. Perfect. So I will be opening the collab now. For now, we will be generating the synthetic data, artificial data, dummy data, and we'll be working on that, right? So we can rename this file to clustering implementation, and we can connect this with a server. Now, how many of you aware about this function called as make underscore blobs in sklearn? So this specific method is actually used to generate the synthetic data, which is we can use for the clustering purpose. So we will try to use this specific method to generate whatever with the number of samples you will specify. If you won't specify, it will take by default 100 samples, but maybe we can take more than that. For now, first of all, we need to import all the required libraries. So let's do that. Let's import all the required libraries. So how can we import that? We can say import numpy as np, pandas, matplotlib, dot pyplot as plt, and then from sklearn dot datasets, we can import make underscore blobs. Done. Once it is done, the next task is to generate the data, or maybe we can do in a next code block. Let's do that. Now let's do second thing is to generate the data set. तो कैसे generate करेंगे? We can say x comma make underscore blobs Number of samples we can specify and underscore samples. 500 ले लेते हैं अभी के लिए. Centers, let's specify it as 3. Cluster standard deviation, maybe 0.60. Random state. Now all of these are the parameters that I'm defining just to make sure we all will get a similar sort of data. And I will showcase you how the data will look like. So plt.scatter, I will try to create a scatter plot where I will showcase you all the rows, 0th column, and then all the rows, first column, maybe 50 points. So here now, maybe we can say plt.title, and here we can define this is a unlabeled synthetic data. Oh, unlabeled synthetic data. Then you can define plt.xlabel. xlabel में हमारे पास क्या है? Feature 1. plt.ylabel. ylabel में हमारे पास क्या है? We have the second feature, second column. So you can say we have feature 2. And you will be able to see that how these features are connected with each other. So can you see here we will be having 500 samples. Number of centers over here, you can say 3 centers are there. Cluster standard deviation is 0.60. So basically this is how I have created a synthetic sample data. Now in this specific data, I don't have any labels. So if I'll just try to showcase you how it looks like as an X. So you can see I just have this 2 features value available, F1 and F2. I don't have any target available. So now what I want is I want to apply the clustering approach, the very first approach called as k-means clustering, to make the clusters out of it. So now sometimes it is very intuitive that how many clusters you should make. Now if let's say you are trying to plot your data and your data looks like this. So if I'll ask you in this specific kind of a data, what should be the value of k? So can you tell me intuitively what should be the value of k? It will be 3, right? 3 clusters banne chahiye because the data is looking like this only, the way it is being linked. So how basically we can create that? So from sklearn, because we are learning today about clusters, so we have a cluster module. Inside this, we can import the specific model called as k-means. Now, k-means is equals to, you can call directly this model of k-means. Inside this, you can specify how many number of clusters you're looking for, which is 3. And you can specify the random state as well. Now, once it is done, if you want to see the labels in the k-means, because that is what the clusters that you have created, so you can say k-means dot fit underscore predict on top of this X. So now if I will just try to showcase you corresponding to every X, we will be having this labels. You can see either it will be 0 or it will be 1 or it will be 2. So somehow for every specific record, now you will be having its linked labels, linked clusters, which is done by the k-means clustering algorithm. Now somehow using this technique, you have actually make the records labeled. So you will be able to form this clusters. Now if you want to showcase this, you can showcase this as well. So you can say plt.scatter, and inside this you can say X, all the rows 0th column, like the way we have created. all the rows first column, and then you can specify. So if you will see the method of plt.scatter and its parameters, you will get the idea what we are defining over here. So you can see S indicates the marker size in the points. So I have defined that marker size as 50 if you remember in my case. What does the C indicates? C indicates the marker colors, possible values. So let's define that now. C is equals to, here I am defining it as label underscore k means, उससे डिफ्रेंशिएट हो जाएगा बहुत इजीली. एंड कौन सा कलर अगर आप नहीं भी रिप्रेजेंट करोगे तो वो अपने आप ले लेगा. एंड एस इज इक्वल्स टू 50. लेट्स सी. कैन यू सी? क्लस्टर्स के बेसिस पे ही डिफरेंट डिफरेंट हमारे पास कलर्स आ गए. एंड वी विल बी एबल टू सी द स्कैटर प्लॉट फॉर द सेम. देखा आप लोगों ने? ऑल गुड? Now, if you want to check the centroids, the centers for the same, you can say plt.scatter. So let's see one function over here. K-means dot cluster underscore centers underscore. All the rows for the 0th column. And the same thing we can do. All the rows first column. You can represent it with the red color. You can represent the marker also. Maybe X. S is equals to 200. You can define. And label also you can define as centroids. Again, you can say plt dot show. एक और चीज मैं शो कर देती हूँ. कैन यू सी? वही सेम ग्राफ जो हमने अभी थोड़ी देर पहले गीक्स फॉर गीक्स पेज पे देखा था. हैव वी एबल टू क्रिएट दैट? So can you see the centroids in the middle? These are the fixed centroids that we will be having. So whenever you will be using this kind of a function, k-means dot cluster underscore o, cluster underscore centers. So this will give you actually the position of the centroids that you will be having. तो 3 clusters हैं तो obviously 3 centroids होंगे, आपको वो position मिल जाएगी. तो हमने क्या किया, हमने इसी मेथड को यूज किया और बोला कि सभी रोज के कॉरस्पॉन्डिंग 0th और फर्स्ट मतलब फीचर 0 फीचर 1 में वी हैव ट्राइड टू लेबल्ड इट एक्स एक्सिस और वाई एक्सिस के अंदर विद अ रेड कलर मार्कर, द साइज एंड द लेबल. सो दिस इज व्हाट वी विल बी एबल टू गेट. ऑल गुड? समझ में आया? इज द अंडरस्टैंडिंग ऑफ के मीन्स क्लस्टरिंग एल्गोरिथम इज क्लियर टू एवरीवन? Any doubts till so far, anyone? No doubts? चले आगे. Now the next question, which is asked by one of the learner few minutes back, ki how can we get this value of k? One way is intuitive. Just now I have talked about, just by looking into the data associations in the graph. You can just imagine intuitively. You can examine that what should be the best value of k we can have. But if that is not the case, in that case, you can use an elbow method. What this method says with respect to k-means clustering algorithm, this method is a graph between the value of k and the value of WCSS. And today we have to understand what is the meaning of this. WCSS की full form होती है within cluster sum of squares. Within cluster sum of squares. So it is actually trying to find out the difference between the points and the clusters that we will be having. So let me just showcase you its formula as well. Yep, we can take this picture. Just give me a second. So I hope this image is pretty much visible to everyone. Is this visible? Within clusters, sum of squares. What does that mean? Let's say we have 3 clusters. Now, obviously, every cluster will be having its centroid, C1, C2, C3. So what it will do, first of all, it will try to find out the distance of every point with respect to the cluster C1. Then cluster C2 distance, cluster C3 difference, and the distance, and the square of that. So this is what we call as sum of squares. Yes, हमने क्या किया, जो हमारे पास क्लस्टर C1 था उसका डिस्टेंस हर एक पॉइंट से क्लस्टर 1 के उसको निकाला और उसके ऊपर उसका स्क्वायर कर दिया. दैट इज व्हाट द फर्स्ट पैरामीटर इज ऑल अबाउट. ऐसे ही सेम चीज हमने क्लस्टर 2 के साथ करी, ऐसे ही हमने सेम चीज क्लस्टर 3 के साथ करी. So we'll get the values and then we have combined all of them to get overall within cluster sum of squares. क्या ये बात क्लियर हुई? Is this clear? समझ में आया? तो हमने क्या किया, हर एक क्लस्टर का डिस्टेंस निकाला उसके सेंट्रॉइड से, उसका स्क्वायर कर दिया, तो वो तो हो गया सम ऑफ स्क्वायर. 3 क्लस्टर्स है तो 3 आपके पास अलग अलग वैल्यूज आएंगी सम ऑफ स्क्वायर्स की. तो इसको बोल दो SS1, इसको बोल दो SS2, इसको बोल दो SS3. 3 क्लस्टर्स है, सम ऑफ स्क्वायर 1 आया, सम ऑफ स्क्वायर 2 आया, सम ऑफ स्क्वायर 3 आया. तीनों को इंडिविजुअली ऐड कर दो, जो हमारे पास आंसर आएगा वो होगा WCSS विद इन क्लस्टर सम ऑफ स्क्वायर्स. इज दिस क्लियर टू एवरीवन? चले आगे. ऑल गुड? ठीक है जी. अब मुझे एक बात बताओ, व्हेन यू इंक्रीज, अच्छा, व्हेन द वैल्यू ऑफ k इज 1, जब हमारे पास सिर्फ एक ही क्लस्टर होगा, इन दैट केस व्हाट विल बी द वैल्यू ऑफ WCS? विल इट बी हाईएस्ट or will it be lowest? And when you increase this value of k from let's say 1 to maybe अभी 9 लिख देती हूं मैं, मतलब जब आप नंबर ऑफ क्लस्टर्स को बढ़ाओगे तो WCSS बढ़ना चाहिए या घटना चाहिए? दैट इज द क्वेश्चन व्हिच आई एम आस्किंग. Basically, as the value of k increases, WCSS will become highest or lowest? That's my question. जब k की वैल्यू 1 है, इमेजिन करो कि आपके पास एक ही क्लस्टर है, मतलब एक ही सेंट्रॉइड है, लेट्स से कि ये सेंट्रॉइड है, और आपके पास सारे डेटा पॉइंट्स यहां पे अवेलेबल थे। बट अब क्योंकि सेंट्रॉइड एक ही है, तो आपका WCSS क्या होगा? इस स्पेसिफिक सेंट्रॉइड के विद रिस्पेक्ट सबका डिस्टेंस निकालना, उसका स्क्वायर करना, वही आपका सेंट्रॉइड होगा, राइट? फिर आपका क्या हुआ? आपके क्लस्टर्स बढ़ते गए, अब आपके पास दो क्लस्टर हो गए। एक क्लस्टर में सारे चिपके हुए यहां पे हैं और एक क्लस्टर के यहां पे हैं। तो WCSS क्या हुआ? इंडिविजुअली हमने इसका सम ऑफ स्क्वायर निकाला, इसका सम ऑफ स्क्वायर निकाला, जो भी वैल्यू आई इन दोनों को हमने ऐड कर दिया। तो मुझे एक बात बताओ कि WCSS की वैल्यू पहले वाले केस में ज्यादा होगी या दूसरे वाले केस में ज्यादा होगी? WCSS की वैल्यू पहले वाले केस में ज्यादा होगी, जहां पे आपके पॉइंट्स कुछ इधर हैं कुछ उधर हैं, बट सेंट्रॉइड क्योंकि एक ही है, डिस्टेंस हमें निकालना है, तो वहां पर ज्यादा आएगा? या फिर जब आपके सेंट्रॉइड्स बढ़ते जा रहे हैं, पास आते जा रहे हैं डेटा पॉइंट्स के, वहां पर ज्यादा आएगा? सोचो थोड़ा। इन फर्स्ट इट इज मोर। विल यू गाइस एग्री विद मी? फर्स्ट केस में ज्यादा होगी, राइट? तो इसका मतलब ये हुआ कि जब k की वैल्यू 1 होगी तो WCSS हाईएस्ट होगा। अब जैसे जैसे आप k की वैल्यू को बढ़ा रहे हो, इसका मतलब आपके क्लस्टर्स बढ़ते जा रहे हैं, टाइट होते जा रहे हैं, डेटा पॉइंट्स पास होते जा रहे हैं। तो जैसे जैसे आपकी वैल्यू बढ़ेगी, तो कैन आई से आपका WCSS घटता जाएगा, इट विल बिकम लोवेस्ट, कीप्स ऑन डिक्रीजिंग, क्योंकि हर एक क्लस्टर, जैसे आप क्लस्टर को बढ़ा रहे हो तो स्मॉल होता जाएगा, टाइट होता जाएगा, और डिस्टेंस कम होता जाएगा, तो वैल्यू ओवरऑल डिक्रीज होती जाएगी। क्या ये बात मैं बोल सकती हूँ? इफ यू गाइज अलाउ मी, सो कैन आई से द कर्व विल बी लाइक, सबसे पहले ज्यादा होगा, फिर घटेगा, फिर घटेगा, फिर घटेगा, देन एक ऐसा पॉइंट आएगा, जैसा हमने लास्ट डिस्कशन में भी डिस्कस किया था, कि देर विल नॉट बी एनी शार्प डिक्रीज इन दिस वैल्यू ऑफ WCSS। अब वो पॉइंट लेट से के वैल्यू किस पे आता है? मे बी 3 पे आता है, तो उस केस में आप बोलोगे कि नंबर ऑफ क्लस्टर्स 3 होने ही सही है। इसी को हम बोलते हैं एल्बो मेथड। तो एल्बो मेथड क्या है? इट्स अ ग्राफ बिटवीन द वैल्यू ऑफ के इंडिकेट्स ओवर हियर नंबर ऑफ क्लस्टर्स and WCSS within cluster sum of squares, and as the value of k increases, WCSS will keep on decreasing. It will reach to a point where after that, if even though you will increase the value of k, WCSS won't get decreased much. So kind of an elbow is forming up, and that is where we will fix that value of k. समझ में आया? Clear हुआ what I am trying to convey over here? Shall we try to create this elbow in our work, in our implementation? Shall we try? By the way, this WCSS in a technical terms in machine learning called as inertia. So there is a method we called as dot inertia underscore. I will showcase you, which will help you to give this WCSS value. How will it evaluate? Formula is with you. I hope it is clear to everyone. But we'll not do manually. We will have direct methods. We can use them to access this value of WCSS. But before that, going to the again implementation side, ask me if you have any questions, any concerns. Otherwise, we can proceed ahead. Can I get a quick confirmation from everyone? All good? So let's try to create the elbow graph. Let's do that. So we can say WCSS, we can create one list. We can say K range, and we can specify this range from, let's say, 1 to 10, let's say. Now we can say for K in K underscore range. Sorry. Inside this, we can specify, we can call our model of K means. And inside this, we can say number of clusters, जो कि हमारे K के equal है, and random state, which we can define as 44, right? K means dot fit, and inside this, we can specify the value of X. X is the input features that we will be having. With respect to every value, we will keep on evaluating the WCSS and appending in the list. How can we evaluate? You can say K means dot inertia underscore. This inertia underscore will be helpful to provide the value of the WCSS, which you are storing over here, right? Now, if you want to create a plot, you can say plt dot figure. Inside that, you can define the fig size, which may be 8 cross 5. Then you can say plt dot plot. In the x-axis, you will say, I will take K range. In the y-axis, you will take WCSS. And marker you can specify as O. Done. Now you can specify the title. You can say elbow method for optimal K. You can specify the X label, which indicates the number of clusters, right? Then we can specify the Y label. Y label indicates within cluster sum of squares, WCSS. Then we can say plt dot show. Perfect. Now, if I'll ask you what is the optimal value of K in this specific curve, in this specific data, for us, it is 3, which is absolutely correct. We already have used 3 intuitively. And here it signifies also that 3 is the best value. Is this clear? If WCSS value coming nearby, then starting value will be considered K value. That's true. That's true. So you can see now here elbow is forming up, right, everyone? So here we can clearly see this elbow, right? और ये point क्या है? ये 3 है, जिसके बाद इतना decrease हो ही नहीं रहा है. So now we can say that this is the best optimal value of K. Clear हुआ? All good? Perfect? Make sense till so far whatever we have covered up? Any doubts, please ask before we will proceed ahead. Yes, any doubts, anyone? Can I get some yes, no, hand raise if anyone wants to come on stage, any interaction, so that I get to know that I am speaking to you guys and not speaking to the camera, because I'm not doing any recording of the topic. I think I'm teaching in front of many people. No doubts. Very good. Very good. Now, with that, K-means clustering algorithm topic is over. And we need to start now the new topic, which is about the next topic is hierarchical clustering. Hierarchical clustering. Perfect. The next topic is hierarchical clustering. Now, what this method says, इसके लिए भी कुछ इंटरेस्टिंग सा प्लॉट निकालते हैं. Hierarchical clustering in machine learning. Yep. So you can see, for example, let's say कि हमारे पास कुछ points available है. Maybe we have this point P1, this point P2, this point P3, this point P4, maybe this point P5. So let's suppose we have 5 points available with us, right? अब यहाँ पे अगर आप ध्यान से देखो, so what this hierarchical clustering says, it says that find the nearest points and combine them together. So ये क्या करेगा? It will try to create something called as a dendrogram. So what it will do, the intuitive idea is कि आपके पास let's say अगर 5 points हैं, so it will first of all merge P1 and P2 together. ठीक है? It will first of all merge the P1 and P2 together. Why? Because P1 and P2 is having a least distance with each other. And let's suppose P3 और P4 का distance भी आपस में सबसे कम है. So it will again further merge the value of P3 and the value of P4. So here also you will be able to observe that it is somehow trying to merge this P3 and P4 as well. Okay? So we have P1 and P2 and we have P3 and P4. Now let's suppose further we have the point P5. Maybe the P5 point is nearby to P1 and P2. So further it will again merge these 3 points. तो यहाँ पे क्या होगा? Here we will be having P1, P2 and here we will be having P5. ठीक है? After this, obviously you will be having these two, P3, P4 and this complete cluster. So this will be able to form one entire cluster altogether, right? As per the distance metric. तो ये हमारा हो गया. And this is what we called as a dendrogram. तो यहाँ पे हमने किया क्या? Just try to observe over here. हम यहाँ पे initial number of clusters को define नहीं कर रहे. So you will be able to observe कि K-means की सबसे बड़ी problem ये थी कि K-means के अंदर हमें starting में ही value of K को define करना पड़ रहा था, right? हाँ ठीक है, हमारे पास methods हैं, but definitely it's a trouble, it's a pain point कि हमें अपने एल्गोरिथम को स्टार्ट करने से पहले एक स्पेसिफिक पैरामीटर ढूंढना पड़ रहा है, एक ऑप्टिमल वैल्यू ढूंढनी पड़ रही है और हमारा पूरा एल्गोरिथम उस पर रिलाई कर रहा है. तो रिसर्चर्स ने सोचा कि व्हाट एल्स वी कैन डू टू अवॉइड दिस काइंड ऑफ अ प्रॉब्लम. कैन वी हैव सम अदर क्लस्टरिंग टेक्निक्स इन विच we don't need to specify as such any value of K. And that is where this hierarchical clustering comes into picture. It says that you start combining those points which are very close to each other. And once you do that, you will try to form a final cluster. और यहाँ पे अगर आप देखो, so we will be having at the very end, when you create one line together, whatever be the number of points you can see on lying on that specific line will actually indicates the count of the number of clusters in that case. That is a simple hack which they have used. So if you will again go back over here, so you can see a dendrogram is like a family tree for clusters. It shows how individual data points or groups of data merge together. Bottom shows each data point that the way I have also created. So P, Q, R, S, T, U. So you can see P and Q are closer, they have joined. T and U are closer, they have joined. Now T and U combined together is closer to S. And then S, T and U combined together is closer to R. And finally, P and Q overall is very much closer to this RSTU. And finally, we will make one final dendrogram. Now, when you make this final dendrogram, you have to just check how many lines are actually in the final dendrogram coinciding when you create a straight line. 2 points, it means 2 clusters are required. That is the actual idea behind what I will say hierarchical clustering algorithm. So you can see over here that it's at the bottom, they all are separate, P, Q, R, S, and T. As you move up, the closest points are merged into a single group. The lines connecting the points show how they are progressively merged based on the similarity. The height at which they are connected shows how similar the points are to each other. Shorter the line, the more similar they are. So that is the main approach of what we called as hierarchical clustering. Does that make sense? Is this clear to everyone? कैसे काम कर रहा है और कैसे ये ऑटोमेटिकली पता कर रहा है कि कितने नंबर ऑफ क्लस्टर्स जो है इसके अंदर होने चाहिए? समझ में आया? तो जो प्रॉब्लम थी के मीन्स की जहां पे हमें के को डिफाइन करना पड़ रहा था, वो प्रॉब्लम यहां पे ऑटोमेटिकली रिमूव हो गई. ऑटोमेटिकली इसने के को डिफाइन किया और अकॉर्डिंगली इट विल ट्राई टू मेक द क्लस्टर्स. अगेन बेस्ड ऑन डिस्टेंस ही यहां पे हो रहा है कि जो क्लोजेस्ट हैं, जो सेम कैटेगरी से बिलोंग करते हैं, जो सबसे मिनिमम डिस्टेंस पे लाया करते हैं, उनको बस मर्ज करते हुए जा रहा है. दैट इज द होल आइडिया एंड फाइनली इट विल ट्राई टू शो केस द डेंडोग्राम एज वेल. समझ में आया? क्लियर है सभी को? ऑल गुड? Shall I showcase the implementation for the same? If you guys will allow me. Perfect. So let's try to go further now. And here we have something called as hierarchical clustering. Okay? Now, from sklearn.cluster में ही available होगा because it is again a clustering technique. We need to import something called as agglomerative clustering. Right? Yes. उसके बाद प्लॉट करने के लिए डेंडोग्राम को इफ आई हैव टू शोकेस यू, तो यहां पे स्काईपाई के अंदर आई कैन सी देयर इज अ inside cluster one hierarchy module from which we can import dendrogram and linkage. So अभी डेंडोग्राम में आपको शोकेस करती हूँ एंड देन वी विल सी. लिंकेज भी मॉड्यूल इंपोर्ट करना पड़ेगा. लेट मी इंपोर्ट दैट. Now, first of all, let's try to create a model, hierarchical model, और इसके अंदर we can call agglomerative clustering. Inside this, we will define the number of clusters. अब कितने number of clusters हमें create करने? That is something which you don't supposed to define, but for now, because we know that here in this specific case, we will be using 3 number of clusters. We already have worked on that, so I'm just mentioning over 3. After that, just try to use that fit method, fit underscore predict method on top of this X. Once it is done, we will use a scatter plot. X, all the rows, 0th column. X, all the rows, 1st column. C is equals to labels underscore. अभी हम hierarchical model use कर रहे हैं, right? So labels underscore Sorry, hierarchical model. ठीक है. S is 50. PLT dot show. We can make a title as well. And we can define over here hierarchical clustering result. Let's see. कुछ तो गड़बड़ हुआ है. इस मॉड्यूल में कुछ इशू है. लेट मी चेक फर्दर. अभी के लिए इसको हटाते हैं. Float argument must be not agglomerative clustering. Spelling mistake is there. Agglomerative clustering. What is the issue? Value हमारी x में ही store है ना? Let me recheck once. Yes. All the rows, 0th column. All the rows, first column. Oh, we are not using the variable over here. Labels hierarchical. And here we go. Again, you can see over here, we will be able to get the clusters just like the way we got in k-means, but obviously the internal intuition is different over here. The problem was I have not stored this in the variable. So when I'm choosing this C part to create the cluster, I'm not able to get the correct result. So just like the way in the above part in k-means, we have stored it in a variable of labels underscore k-means, if you remember, right? हमने store किया था जब हम fit underscore predict को use कर रहे थे. ऐसा ही कुछ हमें यहाँ पे करना होगा. Then only we will be able to create a plot. We don't need training in this anyway. जब आप fit underscore predict use करते हो तो this specific method is composed of two methods, fit and predict. Fit क्या करेगा? जो आपकी internal approach है, agglomerative की हो गई या k means की हो गई, उसके बेसिस पे आपको आपके डेटा को ट्रेन करेगा, राइट? दैट्स वेयर ट्रेनिंग इज हैपनिंग डिपेंडिंग अपॉन द मैथ्स दैट वी हैव कवर्ड अप जस्ट नाउ. और प्रिडिक्ट क्या करेगा? फिर फर्स्टली फिटिंग होगी, फिर प्रिडिक्टिंग होगी. प्रिडिक्शन मीन्स कि उसके कॉरस्पॉन्डिंग हर एक इनपुट सेट पे क्या आउटपुट लेवल होना चाहिए, क्या क्लस्टर होना चाहिए. सो यहां पर भी ट्रेनिंग हो रही है. इट्स जस्ट दैट वी आर जस्ट यूजिंग डायरेक्टली द टू फंक्शंस टुगेदर. दैट इज योर a wish. If you want to use one by one, pehle fit or fit predict, you can use that as well. Fit underscore predict is usually used in clustering part because in this way, all in all, both of the things we can do, fit as well as the predict. That is the main reason. All good? समझ में आया? चलें आगे. टेस्ट स्प्लिट ऑब्वियसली वी डोंट रिक्वायर्ड, क्योंकि हमें इनपुट फीचर्स के कॉरस्पॉन्डिंग ही तो क्लस्टर्स चाहिए। यहाँ पे जो टेस्टिंग वाला पार्ट होगा वो प्रोडक्शन साइट पे जो हमारे पास नया टेस्ट डेटा आ रहा है वही होगा। वहां पर सुपरवाइज्ड के अंदर ट्रेनिंग टेस्टिंग स्प्लिट करने का रीजन था एक्यूरेसी निकालना। रीजन था, अगर हम रिग्रेशन प्रॉब्लम पे बात कर रहे हैं तो एमएसई निकालना, मीन स्क्वायर एरर। तो हम कंपेयर करते थे एक्चुअल और प्रेडिक्टेड को। यहाँ पे कुछ ऐसा तो होना ही नहीं है, राइट right? तो यहाँ की मेट्रिक भी अलग होगी। विल डिस्कस अबाउट दैट। देयर इज समथिंग कॉल्ड सिलहाउटे स्कोर which we usually use to determine that how our clusters are made. तो इस वजह से that is not something which is required. Okay? Does it make sense? चले आगे. Perfect. The last model and the last discussion for today's class is DBSCAN. This is the last clustering algorithm we have, which is very important to know. Density-based spatial clustering algorithm. Now, by the name itself, if you will be able to observe, density-based. What does that mean? Density का मतलब क्या होता है? Volume, right? कि अगर आपके पास कुछ ऐसे clusters हैं जिनमें density ज्यादा है, and density के basis पे you want to classify those clusters, those groups. In that sense, DBSCAN is very helpful. अगर आप मुझसे पूछो इंडस्ट्री यूज केस में कहां पर इसका बहुत ज्यादा यूज हो रहा है, so whatever algorithms we have learned so far is a clustering part. For example, k-means. It is like for the outliers part per se, इतना easily हमें डिटेक्ट करके नहीं देगा कि ये आउटलायर पॉइंट्स हैं। जब भी यू आर डीलिंग विद द आउटलायर्स एंड you want to see that what are the outliers available in my data, and you don't want those outliers to be included as a part of a cluster, that is where DBSCAN will come into picture. So to determine the outliers in your data, DBSCAN is a very widely used algorithm. अब वो कैसे करता है? Let's try to understand that. In DBSCAN there are two important parameters. One is epsilon, जो कि रेडियस को रिप्रेजेंट करता है, या फिर मैं बोलूं कि डिस्टेंस को रिप्रेजेंट करता है, एंड द सेकेंड पैरामीटर इज मिनिमम अंडरस्कोर सैंपल्स. तो व्हाट इट सेज इज, बट देयर आर टू इंपॉर्टेंट टर्म्स, core points in DBSCAN and the border points. We will try to understand what is the meaning of both of them. So let's check if we'll find some interesting article. So I am sharing this article link as well for Hierarchical. We got it. Then we have DBSCAN clustering algorithm. So epsilon, minimum points. That is what the two parameters I have talked about. तो minimum samples की जगह exact word हम लिखने चाहिए minimum points. मिनिमम पॉइंट्स रिप्रेजेंट कि एक क्लस्टर को बनने के लिए डीबी स्कैन के अंदर यू आर डिफाइनिंग कि कितने पॉइंट्स मिनिमम होने चाहिए. सो दैट इज व्हाट वी कॉल एज मिनिमम पॉइंट्स. सो you can see over here, this defines the radius of the neighborhood around a data point. If the distance between 2 points is less than or equal to epsilon, they are considered neighbors. A common method to determine epsilon is by analyzing the k distance graph. If epsilon is too small, most points will be classified as noise. Noise means outliers. If epsilon is too large, clusters may merge and an algorithm may fail to distinguish between them. Minimum points is the minimum number of points required within the epsilon radius to form a dense region. ये सब देखते हैं, but before that, let's discuss about the what happened. Not really sure what happened. Anyhow, let me take this plot. So I hope this specific plot is visible to everyone. This specific uh, graph is properly visible. So here you can see, for example, they have defined the epsilon as 1, minimum points as 4. It means that in order to form a cluster, the radius, the distance between the points will be 1 unit. So if it is 1 unit or less than that, it means that those are the neighbor points. Now what will happen? It will try to see the distance of this middle point, which you can see which you can observe over here. It will take a distance of 1 and it will try to create one circle. Now it will see that how many number of points we have over here. Is this minimum 4 or more than 4? You can count 1, 2, 3, 4, 5, 6, 7. Definitely in this cluster, we do have minimum 4 points, right? So this is something we called it as a valid cluster. ठीक है? तो एक क्लस्टर बनने के लिए हमने क्या बोला? 2 कंडीशन हमने दी. पहली कंडीशन कि द डिस्टेंस विल बी 1 यूनिट. दूसरी कंडीशन कि जो मिनिमम पॉइंट्स होंगे उस क्लस्टर के अंदर वो कितने होंगे? 4 होंगे. तो अगर 4 है या 4 से ज्यादा है तो वो एक वैलिड क्लस्टर हो गया. कोर पॉइंट क्या हुआ? वैलिड क्लस्टर के अंदर जो मिडिल पॉइंट हुआ वो कोर पॉइंट हुआ. So this is what we are calling it as a core point. ठीक है? What is the meaning of a border point? If you will try to create by taking any of the valid cluster point, आप फिर से एप्सिलॉन के बेसिस पे एक सर्कल बनाते हो और उस सर्कल के अंदर आपके पास कुछ ऐसे पॉइंट्स आते हैं which are a part of a valid cluster, which are a part of a valid cluster. तो ये वाला पॉइंट क्या हो गया? This is called as a border point. तो border point क्या हुआ? अगर उस पॉइंट के कॉरेस्पॉन्डिंग इफ यू विल ट्राई टू क्रिएट अ क्लस्टर एंड इन दैट क्लस्टर यू विल फाइंड द डेटा पॉइंट्स which are from the core points altogether, which are from the valid clusters altogether, that is what we call as a border point. तो अगर आप यहां पर देखो तो इस स्पेसिफिक सेकेंड क्लस्टर के अंदर इन अ वे मिनिमम पॉइंट्स 4 हैं और ये जो कुछ पॉइंट्स जो हैं वो ओवरलैप कर रहे हैं. दैट इज अ कंपोनेंट ऑफ ऑलरेडी फॉर्म्ड valid cluster, and that is where we are calling it as a border point. Now the last thing is a noisy point, the point which is not a part of any of the cluster. और इसी को हम क्या बोल रहे हैं? We are calling it as an outlier as well, जिसको यूज करने के लिए यूजुअली DBSCAN को यूज किया जाता है. तो यहां पे अगर आप देखो, if I will just try to see over here again, for each point in the data set, count the number of points within its epsilon neighborhood. If the count meets or exceeds the minimum point, mark those points as a core point. Now, for each core point that is not already assigned to a cluster, create a new cluster. Recursively find all density connected points, that is the points within the epsilon radius. Density connectivity label noise points. So 2 points A and B are density connected if there exists a chain of point where each point is within the epsilon radius of the next, and at least one point in the chain is a core point. So basically, density का नाम क्यों बोला गया? Because you can see over here in this main cluster, maximum points are available, right? ज्यादा से ज्यादा points यहाँ पर आपको available दिखेंगे. इसीलिए इसको cluster कहा गया, density based cluster कहा गया. Now here you will be able to observe noise point. Any point that does not belong to any cluster is labeled as a noise. So this is the simple idea behind the DBSCAN. अब इस iteration के साथ में कितने number of clusters बन पाते हैं, that is depending upon the data points that we will be having. और इस केस में भी हमें by default clusters को define करने की जरूरत नहीं है. Just like the way we have defined in k-means, we can directly use these two parameters, epsilon and the minimum number of samples. Depending upon that, it will automatically start labeling your clusters with 0, 1, 2. If it labels with -1, it means that the point is noisy point. So you can just check this out. And again, there is one video, you can refer that as well for your understanding per se. Is this clear? All good? By the way, you will observe in fact, we do have one sklearn documentation. Not this one. टॉय डेटा सेट पे नहीं देखना मुझे. एक तो कोई पेज है जहां पे उन्होंने प्रॉपर कंपैरिजन करके दिखाया हुआ है. यस, दिस इज द वन. Refer this page. Actually, in this page, you will be able to observe almost all the clustering algorithms are there. So you will observe that DBSCAN is very powerful. Somehow बहुत सारे algorithms में k means fail हो रहा होगा, कहीं ना कहीं agglomerative fail हो रहा होगा, but DBSCAN maximum cases में आपको दिखेगा कि depending upon the type of data that you are having, it is somehow giving us a wonderful results. So it is a very powerful algorithm, especially in those instances where your focus will be on noisy points, where your focus will be on finding the anomalies, finding the outliers in your data. Okay? So I hope it is clear to everybody what I have talked about over here. So you can see clearly over here, सर्कुलर डेटा के अंदर जो मिनी बैच के मीन्स है, ये पहला वाला जो हमने के मीन्स डिस्कस किया, वो कैसे क्लासिफिकेशन कर रहा है, ब्लू और ग्रीन को मिक्स कर रहा है. एक आप डीबी स्कैन का देखो वो कैसे कर रहा है. यू कैन कंपेयर. तो ऐसे बहुत जगहों पे आपको दिखेगा कि कहीं ना कहीं डीबी स्कैन इज डूइंग मच मच बेटर जॉब. सो लेट्स फोकस ऑन द इम्प्लीमेंटेशन साइड एज वेल. सो जैसा कि हमने देखा, डीबी स्कैन में हमारे पास दो ही पैरामीटर्स हैं जो हमें देखना है कि यू नो इम्प्लीमेंट करते हुए ध्यान रखने, एंड दैट इज द मिनिमम पॉइंट्स एंड द एप्सिलॉन वैल्यू. सो we will import them from sklearn.cluster. We can import dbscan, और उसके बाद we can say dbscan is equal to dbscan. Here you can define the epsilon value, maybe 0.5. You can define the minimum underscore sample size. Here maybe we can take it as 5. And after that, again labels underscore dbscan dot fit underscore predict, और इसके अंदर we can define that again x value. ट्रेन कर देते हैं, plt डॉट फिर से स्कैटर प्लॉट क्रिएट कर लेते हैं. सेम चीज हम दोबारा करेंगे. ऑल डेटा पॉइंट्स 0th रो, फिर अगेन ऑल द डेटा पॉइंट्स फर्स्ट कॉलम. सी वैल्यू में हम फिर से लेबल्स अंडरस्कोर डीबी स्कैन को रखेंगे टू चेक कैसे क्लस्टर्स बन रहे हैं. S is equals to 50. plt dot title, you can mention DBSCAN clustering algorithm, and after that we can say plt dot show. रन करेंगे एंड हियर वी गो. तो यहां पे जो आपको अलग से पॉइंट्स दिख रहे होंगे, अलग ही कलर के दिख रहे हैं सभी को? दिख रहे हैं, नहीं दिख रहे? एक तो येलो है, ब्लू है, ग्रीन है, इसके अलावा अलग अलग पॉइंट्स दिख रहे हैं हटके? ऑल ऑफ दीज आर द आउटलायर्स. सो अगर मैं आपको प्रिंट करके दिखाऊं तो आपको कुछ पॉइंट्स दिखेंगे जो कि -1 से रिप्रेजेंट हो रहे हैं. हाँ, पर्पल कलर से -1, ज्यादा नहीं है पर थोड़े से है. -1, -1, -1, -1. यू कैन चेक. कुछ पॉइंट्स हैं जो -1 से रिप्रेजेंट हो रहे हैं, वो सारे पॉइंट्स यही है. तो 7-8 पॉइंट्स हैं हमारे पास जो कि आउटलायर्स है. तो कभी भी अगर दिमाग में आए कि मुझे इस स्पेसिफिक डेटा के अंदर क्लस्टर्स बनाते हुए आउटलायर्स को भी देखना है, एग्जामिन करना है, तो सबसे बेस्ट मॉडल डीबी स्कैन को ही सोचना. राइट? तो ये सारे जो आपको अलग से पर्पल कलर के पॉइंट्स दिख रहे हैं, ऑल द आउटलायर्स, एग्जामिन करने के लिए यू कैन प्रिंट द लेबल्स, और जहां जहां पे आपको -1 दिख रहा है, 0 1 2 तो ठीक है, 3 क्लस्टर्स हो गए, बट जहां जहां पे -1 दिख रहा है वो सभी आउटलायर्स हैं, और वही एक्चुअली पर्पल डॉट्स को रिप्रेजेंटेशन कर रहे हैं। समझ में आया? ऑल गुड? कैन आई गेट अ क्विक कंफर्मेशन? लास्ट टॉपिक डिस्कस करें, इवेल्युएशन मेट्रिक, एंड देन आवर टॉपिक विल बी ओवर एंटायरली। कि जो क्लस्टर्स हमने आज क्रिएट किए उनको इवेल्युएट कैसे करेंगे, कि ये अच्छे हैं खराब हैं, हमें क्या पता, क्योंकि हमारे पास अब वो तो है नहीं टेस्ट डेटा कि हम कंपेयर कर लें। एंड दैट इज वेयर वी हैव अ वंडरफुल कॉन्सेप्ट कॉल्ड एज सिलहाउटे स्कोर। तो यहाँ पे आपको मिल जाएगी इसकी अच्छी खासी डेफिनेशन। एक ग्राफ भी हुआ करता था विकीपीडिया पे, पता नहीं इन्होंने हटा दिया है क्या। परफेक्ट, आई होप इट इज विजिबल। तो ये क्या कहता है, यू कैन सी द फॉर्मूला। Silhouette's score is nothing but B of I minus A of I divided by maximum of A of I comma B of I. So it says कि you can try to find out. So this is one cluster. This is second cluster. Now, for a single point, you can try to find out the distance between the within clusters जो कि A of I और B of I के हैं। अब आप क्या करोगे, B of I minus A of I, इसकी जो वैल्यू होगी, मुझे एक बात बताओ, क्या ये वैल्यू पॉजिटिव होनी चाहिए टू मेक इट अ बेटर क्लस्टर, ये नेगेटिव होनी चाहिए? बी ऑफ आई क्या रिप्रेजेंट कर रहा है, डिस्टेंस बिटवीन आई एंड इट्स नेक्स्ट नियरेस्ट क्लस्टर सेंट्रॉइड, और ए ऑफ आई क्या रिप्रेजेंट कर रहा है, डिस्टेंस बिटवीन आई एंड ऑल ऑफ द अदर पॉइंट्स इन इट्स ओन क्लस्टर। तो ए ऑफ आई रिप्रेजेंट कर रहा है उसके खुद के क्लस्टर्स के बीच का डिस्टेंस। जैसे मान लो ये क्लस्टर है, उसके साथ में जितने भी उस क्लस्टर के अंदर पॉइंट्स हैं वो ए ऑफ आई है। बी ऑफ आई क्या है, यू कैन सी विद येलो मार्कर, इस क्लस्टर का, इस पॉइंट का दूसरे सेंट्रॉइड से कितना डिस्टेंस है। तो दैट इज व्हाट वी आर कॉलिंग इट एज अ बी ऑफ आई। तो व्हाट आई एम सेइंग इज, जो बी ऑफ आई का डिफरेंस होगा ए ऑफ आई से, क्या वो पॉजिटिव होना चाहिए या नेगेटिव होना चाहिए टू मेक इट एज अ गुड क्लस्टर? बी ऑफ आई का डिस्टेंस ए ऑफ आई से पॉजिटिव होना चाहिए, नेगेटिव होना चाहिए टू मेक इट एज अ गुड क्लस्टर? तो हमने क्या कहा, बी ऑफ आई क्या है, डिस्टेंस बिटवीन आई एंड द नेक्स्ट नियरेस्ट क्लस्टर सेंट्रॉइड। और ए ऑफ आई क्या है, दिस इज द एवरेज डिस्टेंस बिटवीन आई एंड इट्स ओन क्लस्टर। फिगर से बहुत क्लियरली विजिबल भी हो रहा है ये चीज कि व्हाट एक्चुअली इट इज रिप्रेजेंटिंग। तो बी ऑफ आई ए ऑफ आई से ज्यादा होगा या कम होगा, दैट इज माई क्वेश्चन। बी ऑफ आई, इज दिस मोर देन ए ऑफ आई, और बी ऑफ आई शुड बी लेस देन ए ऑफ आई? सबसे पहले ये बताओ, बी ऑफ आई और ए ऑफ आई की डेफिनेशन क्लियर है? Yup. Is it clear? What is the meaning of B of I and A of I? Yes, no, any other answer? Can I get some quick confirmation over here? क्या हुआ? Any answer in the chat? Anyone wants to raise the hand? Any confirmation? थक गए क्या? Am I audible? Are you guys still here or sleeping? Okay, someone responded. B of I बड़ा होना चाहिए A of I से. बिल्कुल ठीक बात है. This is a correct statement. मतलब कि सिलहाउटे स्कोर हमारा पॉजिटिव होना चाहिए. That's what I want to say. अगर आपका सिलहाउटे स्कोर नेगेटिव आ रहा है एज पर दिस फॉर्मूला, तो स्पेसिफिक केस में इसका मतलब आपका क्लस्टर इतना अच्छा नहीं है. यू आर नॉट हैविंग अ यू आर नॉट having a good cluster in that case. So you will try to find out this value, and if this value is coming out to be positive, near to +1, it means it's a good deal. Otherwise, it means that it's a bad idea. So quite simple. What will we do over here? Um, so we can do one thing. We can directly from sklearn dot metrics, we can import सिलहाउटे स्कोर. ठीक है, और उसको इंपोर्ट करके वी ऑलरेडी हैव इंप्लीमेंटेड के मीन्स, राइट? सो वी कैन से स्कोर इज इक्वल्स टू सिलहाउटे स्कोर. यहां पे वी कैन राइट आवर एक्स and the value label which we are getting, labels underscore k means, and then we can print what is the score we are getting. And you can see this is 0.83. So this is near to +1, right? पॉजिटिव साइड में जा रहा है, और 0.8 है, मतलब कि 83% आपका क्लस्टर बेटर है. सो इट्स अ मच बेटर वैल्यू. यू कैन कंपेयर दिस स्कोर विद द अदर labels also, hierarchical के अंदर और DB scan के अंदर, and you can compare which one is giving us the better cluster value. But this is a simple way, simple metric to create the better clusters, to evaluate that how much they are better, and to get a sense of ki whether we are creating a good clusters or not, right? So that's the overall idea about today's discussion in the clustering part. Majorly we have focused on three aspects of clustering. वैसे तो clustering के और भी models होते हैं, but these three are the very widely used clustering methods: k-means, hierarchical and DB-scan. k-means के अंदर हमने देखा कि कैसे वो डिस्टेंस के बेसिस पे, फॉर एग्जाम्पल यूक्लिडियन डिस्टेंस हो गया, इनिशियली वो सेंट्रोइड को इनिशियलाइज करता है, एंड आफ्टर दैट इट विल ट्राई टू चेंज, कीप ऑन चेंजिंग द वैल्यू ऑफ द सेंट्रोइड अंटिल इट रीचेस टू अ स्टेज जहाँ पे हमारे सेंट्रोइड्स एक फिक्स नंबर पे आ जाते हैं. हायरार्किकल में देखा डेंडोग्राम कैसे बनता है. डीबी स्कैन में देखा कि कैसे डेंसिटी के बेसिस पे क्लस्टर्स बनते हैं. वी हैव एक्सप्लोर्ड अबाउट what is epsilon, minimum points, core points, and the border points. At the very end, we have talked about the Silhouette score, which is basically used to measure the quality of the clusters that we will be having. Plus one actually simply signifies that clusters are very good, well separated. Minus one signifies that they are quite overlapping, not in a good quality. So that is where we have to work further on the clustering part. So that is the overall idea about today's discussion. Now, if you have any questions or any doubts, you can go ahead and ask from me. Otherwise, we can wrap up for today.